whatever. Okay, so 5.7, graphing absolute value functions. Absolute value functions. All right, so number one here, the graph. So what are we talking about? A graph, right? The graph of an absolute value function is a V. Live long and prosper. If you're a Trekkie, right? No, you can't do it that way. It's got to be that way, right? Spock always does it that way. Live long and prosper. All right. I had to practice that a long time when I was a kid to be able to do that. It took me a while, but I got there. All right. I even got to where I can chop it up. All right. Because growing up in the 70s, you had to be able to live long and prosper. It was a Star Trek thing. No, V shape. You've gotta, whenever you see absolute value, your brain has to say V. It just has to. Because when you go to graph this, you've got to expect that V shape, Earth to Daydreamers, hence trouble later on. All right, you got to expect that V shape. You have to. That's the key to these. And students that aren't thinking V draw lines when they graph these. And you got to be thinking V. All right, there's a form. So the graphing form of an absolute value function is, and I should have left you some letters to draw in, but I put them all in there. But this is the form in the blue box, and it's something that you have to pay attention to. It makes life very easy when graphing an absolute value. And that's really what this lesson is about, using that form. Now, the M out in front, we're not going to use a whole lot today. We'll use it more next chapter. We won't use it much today, but we'll use it a lot next chapter. M is the slope. We've talked about it once already this chapter. Here's the second time. We'll develop it in full detail next chapter. We'll develop in full detail next chapter. Madison, I assume those are math things you have on your desk? Very good. So M is the slope. And so what is it again? The vertical change over the horizontal change. We'll do more with that next chapter. I'll show you one aspect of it here. But B is very, very important. And it's really what you've got to be able to do. H and K are the coordinates of the vertex. You say, what is the vertex? Well, it's that point there at the bottom of the V. Very important point. It's the point at the bottom of the V. So H and K are the coordinates. And of course, any ordered pair, the first coordinate is always the what? Which letter is the first one? The X. And of course, the second one is the Y. Well, not only that, the X is always which one? The horizontal or the vertical? Horizontal. By the way, H, horizontal. That should be pretty easy. Say, Mr. Scarfy, why didn't they make it H and V for horizontal and vertical? I don't know. It's them. They, whoever they is, they always mess up. Probably because V is velocity and they didn't want to use V. I don't know. But they used H and K. And H and K is throughout all math. Later on down the road, don't write this. Look up here. You may even see a function like this. Y equals the quantity of x minus 2 quantity squared over 4 plus the quantity y plus 3 quantity squared over 9. And that will be an ellipse. Circle's too big. And there's H, and there is a form of K in an ellipse, in a circle, in a hyperbola, in all kinds of stuff. H and K, H and K, H and K, H and K. They keep popping up, popping up, popping up, popping up, popping up all over the place. So as we learn them now, we'll keep using that same principle all the way through. So H and K are the coordinates of the vertex. Very, very important. Muy importante. All right, I don't even know if I said that right, but sounds good anyhow. Sounds good to me. All right, so C. The function is translated. Now, we don't mean literary translation, like, for example, my daughter translating the Bishlama in, English, the Bible into Bishlama. We're not talking about a translated work like that. Translation in math means to be moved. So to be moved. So the function is translated or moved according to the values of h and k. And I'll show you that in just a moment. But before we do that, let's get down a couple directional aspects. If h is the horizontal, positive h should move you to the right. I'm glad somebody is right. Because what's positive on the horizontal axis? Right is positive, right? And left is, so negative h moves it left. And because the k is the vertical one, positive k moves the function up. And negative k moves it down. All right. So now we know how to move this V shape up, down, left, right. All right, that's the idea. All right, so D here. Determine the coordinates of the vertex and how it is translated. Okay, I've color-coded everything for you. Now, you're looking at this right here, and on your paper, you're looking at this right here, right? The pattern. And clearly you can see h and k. And therefore, the value of h is 7. Notice the color. And notice back in the original, when you have an x minus, you get to read the value of h. Now that's important, and we'll see that later. Say, why is that minus in front? It's the way the math works out. It's just the way it is. If you were to take this and put this on the other side, then it would be a positive. But don't worry about it. It's just read it after the negative. You'll see that happen over and over again, and you'll get used to it. So what is the value of k? Negative 5. Negative 5. So this thing is translated left or right 7? Right 7. And up or down 5? Down 5. Right 7 and down 5. Right 7 and down 5. So let me pause. You guys don't have this on your notes, but let me just show you what's going on. What in the world did I just do? Get out of here. Give me Cartesian, please. Thank you very much. All right. Let me go up here. Woohoo. Okay. So if I were to graph this function, y equals the absolute value of x. That's it. Can anybody tell me what the value of h is? Okay, you're looking at this. Y equals the absolute value of h. This isn't the one we just did. This is the base absolute value function. What's the value of h? Say it if you know it. Okay, does anybody see an h anywhere? Anybody see an h? If you don't see it, its value must be 0. Very good. What is the value of k? 0, right? One person caught on. Look, if I were to write this out in the full graphing form, it would look like this, but it would be real boring. Why would I want to write it like that? Right. Andrew, how old are you? You're not 13 plus 0? But you are. Well, we wouldn't say that. Oh, I'm 13 plus 0. I'm quantity 13 minus 0, close quantity plus 0. right? We wouldn't include those zeros. It's boring. So again, the first one doesn't have those zeros in it because there's 0. All right, but the vertex is 0, 0. If I were to graph this, my vertex would be at 0, 0. Oh, yellow. Cool. And the function would go, trust me on this, just like this way, and just like this way. Okay? The slope gives you the wideness of the V. And right now our slope is 1. There's no m there either. But notice the m is a multiplier of something. If you had just an x, that would be a 1x, correct? Multiplier. Things multiplied have to be 1s when they're not shown. Things added are 0s when they're not shown. All right, I don't know if you're catching all that, but that's the idea. So let me see if I can get all of this at one shot. I don't know if I can. No, give me the V. No, I want the whole V to talk to it. Got to get way off here. Oh, I'm catching all that other stuff. Okay. All right. Let me do one other thing. I'm going to come over top of this with another V. Okay. So make believe that there are arrows on both ends. So what did we just do? We went 7 to the right. Give me what I want here, people. We went 7 to the right, yes, and we went 5 down. There's the graph of the one we just did, of this one. Whoa. Of this one. 7 to the right and 5 down. Pretty cool, huh? And you know, it can be translated anywhere. You know, we could go just 3 to the right and nothing up, down. We could go nothing to the right or left and 3 up. We could go nothing to the right or left and 4 down. We could go 1 to the left and 3 up. We could go 4 to the left and 2 down. You can go all over the place by H and K. See, H and K is translating, is moving this V around the Cartesian plane. H moves it right if it's positive, left if it's negative, and K moves it up if it's positive and down if it's negative. That's what the lesson's all about. Okay? So that's the idea. That is the concept. How do I get rid of all this? Who knows? Like 1,000 backs. Back, 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 back. Yeah. Awesome. All right, let's do another one. Aren't you excited? Oh, come on. It's great. All right. Beware of number 2. Let's do the K first, because now you guys are K experts. And the value of K is 0. Very good. And again, we're not going to write plus 0, because it's 0. However, you have to be astute to get the H correct. Will you be astute? How many don't know what astute means? Great. So you don't know if I'm saying you'll be smart or stupid, do you? All right. Astute means, you're bright, you have good perception, you're, that kind of idea. All right. So the value of H is, I heard it, -3. I will show you how. If I'm going to put it in proper form, I need that negative after the x, don't I? To be able to read H. And therefore, H must have been a -3, right? You got to read it after a negative. Don't we need that negative after the x? Now, would we leave something negative a negative? No. So if we were going to write it as a final answer, we would write it the quantity x plus 3, right? Because we don't leave negatives a negative. But technically, if you want to read the value, it's negative. All right, so what do students do? If the negative's there, just read the number after the negative. If it's a plus there, know it's the negative part of that number. Right? It's not hard. And we do this all the time. You know what? You're going to do that for cycles. You're going to do it for ellipses. You're going to do it for hyperbolas. You're going to do it for everything else with h and k. It's always going to be x minus and then the value of h. All the time, all the way through. Oh, you're going to do it for parabolas. Yeah. All right, so all the time, same stuff. So how is this thing translated? Say it if you know it. Left 3, and that's it. Nothing up or down, right? Left 3. Left 3. That is it. Left 3. All right, so number 3. Everybody now knows that the h value is 0, and the k value is 1/4. And this thing is translated up 1/4. Positive 1/4. Up 1/4. Yeah. Got it? Good. Okay, the next section, we're going to deal with the simplified form of the absolute value function, which means we don't have the m in front. Okay? So a little bit easier to deal with when we want to do what we want to do here. So section 3, we want to write the equation of the function using the template y equals the absolute value of x minus h plus k. Okay? So notice the bold directions. Write the absolute value function as a translation of, and it's giving you that general y equals the absolute value of x. That's the one I showed you a moment ago. Notice there's no multiplier out in front of the absolute value, correct? And that's why we don't have it over here. We don't need m in this one. There is no m. We don't have to worry about it. Okay. So what are we going to do? We're going to look at the directions, and they say what this is telling us is translate that 4 units right and 2 units down. So let's do our right and left first. If we go 4 units right, is that positive 4 or negative 4? Positive 4. Right is positive, left is negative. If we go 2 units down, is that positive 2 or negative 2? Negative 2. Like put the h in for the h and put the k in for the k, right? And I'll even use my color. What is the h? A 4. Are we going to put minus plus 4? No, we just put the 4, right? And what is the k? In that one, we got to use the negative sign and negative 2, right? Y equals the absolute value of x minus 4 minus 2. We just wrote the equation of that absolute value function. Pretty cool, huh? So again, be careful here. You gotta assimilate all this. So can you do the second one? Go ahead and do this. All right. So hopefully everybody said y equals the absolute value of x plus 10 plus 3.7. How many had that as your answer? Awesome. You guys are amazing. Right, and obviously we wouldn't leave negative and negative. We would simplify that into an x plus 10, right? Make sense? Right? We always would simplify. Okay, so that's writing the equation. Number 4, to graph, determine the coordinates of the vertex, parentheses, use your color here, red H, comma, green K, right? To graph, determine the coordinates of the vertex, HK, and use an XY chart to plot enough points to reveal the V shape. Okay, so again, just for clarity's sake, if there were an H shown, what value would go in for H? Say it if you know it. Okay, we're looking at this, right? Notice that's our function. So if we were to put it in HK form, the value of H would be 0. Okay, good. You guys are understanding. Now again, you normally wouldn't do that. You just look at the original and say, oh, H is 0. But I just want to be clear, right? I don't want you guys to not follow. So first thing I want to do is I want to write the coordinates of the vertex. I just put a V for vertex. You can write out vertex if you want. And hopefully you agree the H is 0 and the K is -1. You want to plot this first. Muy importante. This is very important. That's your start with the vertex. At the end of the year, we're going to plot and graph parabolas. And guess how we'll start with a parabola? With the vertex. Very important. You know how we'll graph it? We'll graph the vertex, and then we'll use an XY chart to get the rest of it, just like we do here with our absolute value. So I'm going to take my red. I'm going to go nothing left or right, and I'm going to go down to -1 and put my vertex right there at 0, -1. Now, class, what shape is an absolute value? Right? Now, I gave it to you here, but remember, we're expecting a V shape. So I'm going to choose a value of X 1 to the right of my vertex. So I'm going to go to 1. And I'm going to figure out my XY chart. Remember, this is the value of X. So I'm taking this part of the function, right? And where the X is, I'm going to put in 1. Class, the absolute value of 1 is 1. 1 minus 1 is 0. And now we have the point 1, 0. I'll take my red, and I'll graph the point 1, 0. 1 to the right and 0 up. And look, I already know my V goes off like this. I already know that because, look, I know that this is the vertex. So I know my V because this is a straight line. It has to go like that. And by the way, I already know how the other side goes, but you might not. And to confirm, we're going to go 1 X coordinate to the left, which in this case is -1. And now we're going to figure out who guy -1 is dating. The absolute value of -1 is 1 minus 1 is, oh, that 0 girl, you can't trust her. Right, she's with guy 1 and -1. So plot that point, -1, 0. And do you have the other side of the line now? You do. Does it look like a V? It does. Big newsflash! Newsflash. If your points don't look like a V, what is the only logical conclusion? You made a mistake, all right? If you don't get a V, you made a mistake. I don't know why on tests and quizzes, students know it's a V, and they give me something that's not a V. It's not going to be right. Now, you may have to because you're running out of time. But if you don't run out of time, you know you did something wrong. It's got to be a V. All right, let's get to our last 2 examples. B, graph y equals the absolute value of x minus 1 plus 2. So somebody tell me how to start. How are we going to start? Kirsten? Got to do the vertex. If you are smart, you're going to say the vertex. Let's see, who can I pick on? Adam knows the answer. Adam, what are the coordinates of the vertex? I agree, 1, 2. The h is 1, and the y is 2. I'm going to go to 1, 2, and I'm going to put a red dot for the vertex. Now, I already know how this one's going. So, What value do I want to now use in my XY chart? Now think about this one, because this will help you down the road, especially when the vertex is pretty far away from the origin. Nick? Yeah, so Nick caught on what I said last time. I'm here at the vertex. I need a point to the right, and that point to the right is a 2 for the x, right? We already know 1. 1 is 2. I need one point to the right. I'm going to use a 2. And that is the best way to approach the problem. Okay, so we're going to get the absolute value, of the x minus 1 plus 2. And what is our x? Trying to use my color. It's a 2. So before I calculate it, just everybody look for a second. I just want to make sure you're with me. I took the rule of the function, and where the x was, I put in the 2, right? Everybody with me? Just normal XY chart. So 2 minus 1 is 1. The absolute value of 1 is 1. We all know 1 plus 2 is 3. And where's our next point? At 2, 3, right there. And again, therefore, I know that it goes off to the right like this. By the way, the value of our slopes are always, at least they have been, up to this point, all 1. And that's why it's 1 up and 1 on the right. Now, what's my second point? What do I want to use for my second point? Andrew? 0, because again, Andrew looks and says, we're at 1. What's the point to the left? It's a 0. And now I'm going to put in 0 for the x. So again, you're writing your function, put in a 0. 0 minus 1. Absolute value of negative 1 is 1. 1 plus 2 is 3. Now girl 3 is with 2 guys. Shame on her. But then there's a bunch of girls dating 2 guys. Hence is the life of absolute value. Because it's a V shape. Oh, look, we have a V. And we were expecting a V. And that's just wunderbar. I needed a V. Actually, I don't even think that word begins with a V. Probably a W, wunderbar. I think it's German. Any Germans in here? Germans? Germans? Come on. Wunderbar? Maybe it is a V. Who knows? Who knows? All right. Let's do one more. Let's do one more. Graph f of x, which, by the way, can always be replaced by y, equals 1/2 times the absolute value of x plus 1 minus 3. How are we going to start, Kaylin? How are we going to start? Kaylin, tell me how to start, Kaylin. With the vertex, all right? And again, I'm just trying to be clear. So let's see. Adriana, give me the coordinates of the vertex. And the K is? How many concur? 1, negative 3. One more concurrence, 2 concurrence, 3, 4. We're getting more. We're on a roll. Invitation's open. More conversions, all right, 5. Anybody disagree? Who disagrees? What do you disagreeers think? Wyatt, what do you think? You think it's -1, -3? How many are with Wyatt? All right, we got Wyatt's gang, and then we got Adriana's gang. All right, who's right, Wyatt or Adriana? Remember, you got that nasty plus there, which means it's really 1x minus a -1, right? And it's Wyatt is correct. It's a -1. You got to read the h value when there's a negative in front of it. And if there's not, you got to make a negative in front of it, all right? So it is -1, -3. So I'm going to go 1 to the left and 3 down, and I'm going to put our vertex. All right, everybody look at the screen. So all the way, every other time, don't write this. This one would go like this, right? And this one would go like that, right? Right? So let's not fool with the XY chart, right? Except this one doesn't go that way. All right. Yeah. So we better do an XY chart. Mr. Goodnight, Austin that is, what value would you like to use for X? You could use any value, but the best value would be. All right. Austin's going left side first. I'm good with that. Austin looked at our vertex and he went 1 to the left and said, let's use a -2. All right. I'm going to this original function right here. All right. You got a 1/2. Where the x is, I got to put in his -2. Then I have +1, absolute value symbol, -3. -2 plus 1 is a -1. The absolute value of -1 is 1. 1 times a half is a half. Somebody tell me what a half and a -3 is. Andrew, positive or negative? -2.5. I concur. I would hope, as much as we've done positive and negative numbers in your brain, you could do that. You had a half positive and 3 negatives. The positive half takes away 1/2 of the 3 negatives, yes? Leaving you 2.5 of the 3 negatives. Again, if you can't do that in your brain, then you're just going to have to say, I don't want to do fractions. So if you don't like fractions, go to the next value to the left, all right? Because watch what happens now. Let's put -3 in for the x. So same form, -3 goes in. 3 negatives and 1 positive is 2 negatives. The absolute value of -2 is 2 times 1/2 is, come on, 2 times 1/2. Don't tell me you guys can't do 2 times 1/2. Oh, you're scaring me. You are scaring me. 2 times 1/2 is 2 halves, which is, all right, don't scare me. You scared me. All right, so 1 minus 3 is, see, no fractions. Let's plot that. -3, -2, right up there. -3, -2. Do you concur? Okay. So we got the left side. I need the right side, so I could use 0, right? But guess what? 0 is going to give me a fraction as well. I'm going to go 2 points away. Everybody look up at the function in the box. See that half? If I go 2 points away from the vertex, I won't have a fraction. If I go 4 points away from the vertex, I won't have a fraction. If I go 6 points away, notice all these numbers divide by 2. If I go 8 points away, I won't have a fraction. If I go 10 away, I won't have, from the vertex. Go that far away from the vertex. So if I'm at -1, let me go 2 away, and let me use a 1 for the x. Now, do you have to go 2 away? No, you can do it with fractions, but most of you guys don't like fractions. So that's a way of getting rid of your fractions. 1 plus 1 is 2. The absolute value of 2 is 2. 2 times a half is 1. 1 minus 3 is a -2. Plot the point 1, -2. All right. Draw your V. Notice this V is not as steep, right? Because instead of our slope being a 1, it's now a half. And half is less than 1. So it's less steep. Amazing. Remarkable. Stupendous. Wasn't that a fun lesson? I had fun. All right. Hey, be careful, those of you that are gone tomorrow. Remember, test on Thursday. There is Chapter 5 review on HCS math class. If you want to avail to it. It did end up being about a half an hour, though, I must tell you. And you don't want to take notes over it. You just want to watch it. That's the idea. Does it have everything? No. Does it have most things? Yes.